The universe is a place of incredible wonders. It is vast and full of mysteries. Scientists are always looking out into space. They hope to find new and exciting things. Just recently, in June 2025, astronomers announced something truly amazing. They have found the biggest explosion seen since the Big Bang itself. Imagine the start of everything, the Big Bang. That was an enormous event. These new explosions are the champions of cosmic fireworks since that time. This discovery opens a new window. It helps us see the universe in a new, powerful light. These colossal events have a special name. Scientists call them extreme nuclear transients, or ENTs for short. The word extreme tells you they are very, very powerful. Nuclear means they involve the hearts of stars, their cores. And transient means they don't last forever. They flare up brightly and then slowly fade away. These are not just any explosions. They are in a class of their own. They are far more energetic than anything we have seen before. This discovery was led by Jason Hinkle from the University of Hawaii. His work has truly changed our understanding of cosmic events. So what causes these massive blasts of energy and light? The answer lies with two of the universe's most fascinating objects. One is a supermassive black hole. These are monsters, millions or even billions of times the mass of our sun. They sit at the centers of most big galaxies. The other object is a giant star. We are talking about stars much, much bigger than our own sun. Imagine a star perhaps 10 times the size of our sun, or even larger. When such a huge star gets too close to a supermassive black hole, something dramatic happens. The black hole's gravity is incredibly strong. It pulls on the star with immense force. This force is so powerful it can tear the star completely apart. This process is violent and releases a tremendous amount of energy. This energy is what we see as an extreme nuclear transient. These ENTs are so bright they can outshine entire galaxies. They are a new kind of cosmic event. They are much more powerful than supernova, which are explosions of dying stars. These new discoveries are truly pushing the boundaries of what we thought was possible in the universe around us. Let's delve deeper into what makes an extreme nuclear transient so special. An ENT happens when a supermassive black hole encounters a very large star. We are talking about stars that are at least 3 times the mass of our sun. Sometimes, they can be even 10 times the size of our sun. These are true giants of the stellar world. When such a star wanders too close to a supermassive black hole, its fate is sealed. The black hole's immense gravitational pull takes over. It's a cosmic tug-of-war that the star cannot win. This is the beginning of an incredible cosmic spectacle. The star gets stretched and pulled apart by the black hole's tidal forces. Think of how our moon causes tides on Earth, but on an unimaginable scale. The star is shredded into streams of gas. This material doesn't just disappear into the black hole immediately. Instead, it forms a swirling disk around the black hole. This is called an accretion disk. As the material in this disk spirals inwards, it heats up to incredible temperatures. This superheated material then shines incredibly brightly. This bright shining is what we observe as an ENT. It's a beacon of destruction. These ENTs are different from other cosmic events we know. For example, they are not supernovae. Supernovae are explosions that mark the end of a star's life. While supernovae are very powerful, ENTs are on another level entirely. ENTs can be nearly 10 times brighter than typical tidal disruption events. Tidal disruption events, or TDEs, are when smaller stars are torn apart. ENTs are the big siblings of TDEs. They are also much longer lasting. An ENT can remain luminous, shining brightly for several years. This extended period of brightness is a key signature of these events. The light from an ENT shows a unique pattern. Astronomers observe this pattern in X-ray, optical, and ultraviolet light. The light typically gets very bright very quickly. Then it slowly fades over months or even years. This pattern tells scientists that a black hole is involved. It shows the black hole consuming the material from the disrupted star. Unlike a quick flash of a supernova, this slow feeding process keeps the ENT shining. It's like a cosmic feast for the black hole, and we get to see the fireworks it produces from far away. Scientists have managed to identify 3 of these extraordinary events so far. Each one gives us more clues about these cosmic behemoths. The first one was named Gaia 16 AAW. It was detected back in 2016. The European Space Agency's Gaia mission, a space observatory, first spotted it. Gaia's job is to map our galaxy, but it also finds these transient events. This discovery was an early hint of something new and powerful. It started the journey towards understanding ENTs as a distinct class of cosmic explosions in our vast universe. The second event is called Gaia 18 CDJ. As its name suggests, it was also found by the Gaia mission. This one was detected in 2018. Gaia 18 CDJ was particularly stunning. It released about 25 times more energy than the most energetic supernovae ever recorded. Imagine the power of 100 suns shining for an entire year. That's the kind of energy an ENT like Gaia 18 CDJ can unleash. For nearly a year, it outshone all the stars in its host galaxy combined. These events are truly mind-boggling in their scale and their sheer luminous power. The third event has a more memorable nickname, Scary Barbie. Its official name is ZTF-20 Aberbayu. This anti was discovered in 2020 by the Zwicky Transient Facility. This is an observatory at Caltech in California. Scary Barbie was documented in 2023, and it further confirmed the existence of these super powerful events. These three events, Gaia 16 AW, Gaia 18 CDJ, and Scary Barbie, are now like templates. They help astronomers know what to look for when searching for more ENTs. They are the first examples of a new cosmic phenomenon. Finding these events was not easy. It involved a careful search through vast amounts of data. Scientists used information from public transient surveys. These surveys constantly scan the sky for things that change brightness. Once potential candidates were found, a lot more work was needed. Multi-year follow-up campaigns were conducted. Observatories like the Asteroid Terrestrial Impact Last Alert System, or ATLAS, and the WM Keck Observatory were used. These powerful tools helped confirm the nature of these distant, brilliant explosions. These ENTs are located in incredibly distant galaxies, so their light has traveled for billions of years to reach us. These extreme nuclear transients are more than just spectacular light shows. They offer a rare opportunity for scientists. They allow us to study supermassive black holes that are usually hidden from view. Most supermassive black holes are dormant, meaning they are not actively feeding. This makes them very hard to see. However, when a star gets torn apart, the black hole briefly flares up. Jason Hinkle, the lead researcher, said ENTs are like a spotlight. They shine on these otherwise inactive massive black holes, revealing their presence and properties. Studying ENTs can teach us a lot about how supermassive black holes grow. This is especially important for understanding the early universe. Benjamin Shappy, another key researcher, noted this. He explained that observing these prolonged flares gives insights into black hole growth. This is particularly true during a key era called cosmic noon. This was a time when the universe was about half its current age. Stars were forming rapidly, and galaxies were growing. Understanding black hole activity during this period is crucial for understanding how galaxies like our own Milky Way evolved. One of the fascinating aspects of ENTs is their rarity. They are estimated to be at least 10 million times less frequent than supernovae. This makes each discovery incredibly valuable. Anna Payne, from the Space Telescope Science Institute, commented on this. She said, "We're pushing the upper bounds of what we understand to be the most energetic environments of the universe." These three identified ENTs serve as pathfinders. They help create a blueprint for finding more of these rare and powerful cosmic events. They show us that the universe still holds many surprises. The discovery of ENTs is incredibly exciting for astronomers. It opens up a new field of study. Future observatories will play a big role in finding more. Telescopes like the Vera C. Rubin Observatory and NASA's Roman Space Telescope are expected to discover many more ENTs. With more examples, scientists can learn even more. They can refine their models of how black holes interact with stars. They can probe the conditions in the early universe. These biggest explosions since the Big Bang are not just curiosities. They are keys to unlocking some of the deepest mysteries of our cosmos.